Welcome, friends, to this second session about Kubernetes Fundamentals. My name is Rodrigo, and today we're going to talk about the Kubernetes architecture. We're going to touch upon a lot of topics related to the control plane, and I'm going to describe what the components are and some other related things, okay? So if you're wondering where in the world is session 1, you can find that session in C# Corner Live channels and platforms, okay? So let's do this. Let's do a quick recap about session 1. Remember that we're going to use MiniCube in this series. MiniCube is this application that you can download. It's an open source application for running Kubernetes on your own machine, okay? So you can search for MiniCube and then download, and you're going to find this web page. In here, you can find different options for installing MiniCube, okay? You can download the exe file, and you can also use Chocolatey. That's actually the technique that I used, okay? So, and then you deploy a MiniCube cluster. So for instance, as you can see here, I have MiniCube installed, and I'm running version 1.28. And you can use the MiniCube start command to deploy a Kubernetes cluster on your machine. If you do that, you should pass a driver. You should use a driver here in the driver flag. And MiniCube can use VMware. It can use Hyper-V. It can use Docker Desktop as well. In this session, I'm going to use Hyper-V because in this computer, I have virtualization enabled, and my BIOS is capable of running this kind of virtual machines. So in other words, I'm going to deploy some virtual machines as nodes in a cluster, right? So if I go here, you can see that in this other case, I deployed a cluster with 3 nodes. As you can see here, I have MiniCube and then MiniCube-M02 and M03. Those 3 nodes are grouped as a cluster, and I created them by using MiniCube start. I actually ran the following command, driver Hyper-V, and then I specified the number of nodes. I already executed this command in order to save time, okay? So I deployed this cluster with 3 nodes for this session. So if you install MiniCube, then MiniCube is going to install kubectl. Kubectl is the command line interface for managing and running Kubernetes commands. So for instance, if I run kubectl get nodes, this is going to return all the nodes that are in the cluster that is configured as the default in this machine. So this is particularly interesting because one of those nodes is the control plane node, okay? And the other 2 are just regular worker nodes. Those other nodes are the ones that are going to be used by Kubernetes to deploy your own applications. And I'm going to explain that in a little bit. Okay, so we're going to use MiniCube, run MiniCube. You can install MiniCube by using Chocolatey. And you can use any driver that you want. In this case, I'm going to use Hyper-V, but of course, you can use Docker Desktop, or you can use VMware and some others. That's actually part of MiniCube, and I'm not going to describe all the things that MiniCube does. Okay, so let's go back to the PowerPoint slide, because today I'm going to talk about Kubernetes architecture, right? So maybe you remember this diagram from last session, where I explained that there are two types of nodes in a Kubernetes cluster. Of course, a cluster is a group of nodes, right? Each node in the cluster can see the other nodes in the cluster, right? They have this line of sight between each other. I'm referring to the networking infrastructure underneath it all, right? So any node can see each other. That's important. And here, the control plane is one of the roles that we have in Kubernetes. And the other role that we have is the worker nodes. So let's talk about what in the world is the control plane. The control plane is the brain of Kubernetes. That's where all the services and all the magic happens, okay? So one of the most important components in the Kubernetes control plane is the scheduler. And I'm going to talk about a little bit about that in a minute, okay? So we have two type of nodes, right? Two nodes, two type or role types, okay? Two kind of roles if you want. So the first one is a control plane and the other one is a worker. The control plane is the brain of the cluster. It actually is responsible of the actual orchestration process that happens when you deploy an application. You're actually saying, okay, control plane, please deploy this application to the nodes. And the control plane is going to analyze your application. Actually is going to analyze the YAML file or the commands that you're executing, and it's going to deploy the application to the nodes. You don't know where, okay? That's important. That's one of the decisions that the control plane decides for you, okay? The control plane is the place where every control plane service and component is running, okay? All the services, all the magic is running in the control plane. And on the other hand, we have the worker nodes, and those are where the applications will run, your applications, the applications that you're gonna deploy, right? So the control plane is meant to run the brain of the cluster. It's meant to run the services. But actually, it's not meant to run the applications, right? It's not meant to run your applications. And this is because design decision, and this is because what you want with that cluster is to have the control plane somehow configured for high availability, okay? So that's why in production environments with Kubernetes, the control plane is deployed in 3 to 5 nodes. It's not a single computer in your cluster. That's what I'm meaning here, okay? But of course, that's a topic for another session. Just remember that the control plane is this role or node type that we have in the cluster that has all the magic, okay? So what are those control plane components that I'm talking about? Well, the first one is the API server. I'm going to describe that. And I mentioned the scheduler. I think that's the most important one. And we have a data store for key value pairs. And we have a couple of managers, the controller manager and the cloud controller manager when you're running Kubernetes in the cloud. So first, let's start with API server, okay? The API server is it's just a web API. It's an API. It's not a web API as a regular thing that you create with, I don't know, maybe ASP.NET Core or something. It's an API that Kubernetes exposes for communicating to Kubernetes. That's actually the place and the component that you connect to when you execute some commands by using kubectl, for example. So this is the place and this is the component that you consume all the time, okay? The technical name of this component is Kube API Server. This is a service that is going to be running on the nodes of your cluster, and of course, most of the time, this Kube API server is going to be running on the control plane computer on your cluster, okay? Because remember that with MiniCube, for instance, you can deploy a single computer cluster, right? So that single computer, that single virtual machine or something, it's going to run the control plane components and services, and of course, your applications as well. So this is the front end for Kubernetes, right? So you execute any kind of command and you're communicating to the API server. And actually, this is the only way we can communicate to a Kubernetes cluster, right? So this is the thing that allow us to execute something or configure something in the cluster. It's particularly interesting because it consumes JSON or YAML files. However, in this series, I'm going to use YAML most of the time. Just remember that JSON is also an option. But YAML, I think that's the most important one, and that's the most common one. Actually, if you're looking for passing the Certified Kubernetes Application Developer exam or the Certified Kubernetes Administrator exam, I think YAML is the format that is used in the exam all the time. Okay, and this is a REST API. Okay, this is a REST API in a sense that you execute get commands, you execute delete commands, update commands, and so on. You should know that REST is this kind of technique that we use for creating services, and REST is based on HTTP verbs and notions, right? So this is the first component that I want to talk about. So if I go back here to the diagram, as you can see here, the API is going to be the one that all the nodes and your applications and your tools are going to use to communicate to the cluster. Okay, so let's go back here to the next one, which is the key value data store. So the key value data store, in this case, etcd. etcd is an open source project. It's a distributed key value store for critical data of a distributed system. It actually is a technology for storing this kind of values in a robust way for distributed applications. etcd was written in Go as well, just as Kubernetes and Docker. I mentioned the other day that if I wanted to learn a new programming language, then I would absolutely go for Go, because it's a powerful language, it's a powerful technology, and a lot of cloud native platforms and frameworks and technologies were created with this programming language. So etcd is interesting because it's the place where everything is going to be stored. For instance, if you execute a command, say kubectl, I don't know, deploy something, kubectl change this configuration, kubectl do this other thing, all of that is going to be stored in etcd. Okay, everything is going to be stored in this technology. etcd is based on the RAT consensus algorithm. That's actually the theory behind the technology. There's another algorithm very popular in distributed applications, which is the Paxos algorithm. And RAT is another one. And I think there are other algorithms. It's not that it's quite important right now, but it's nice to know the theory behind that. If you're more interested in that, you can go to the etcd website and learn more about that. So let's search for etcd. I think it's etcd.io. Yes, this is the place. You can learn more about etcd. And here's the documentation and some other things related to this. With MiniCube, this is going to be installed and this is going to be configured for you. Okay, so it's not that it's super important right in this moment. So this is the backend store for all cluster data. As I mentioned before, this is a place where everything is going to be stored. It's not that Kubernetes is using a relational database. Kubernetes is not using other kind of, I don't know, NoSQL database. Of course, etcd could be a NoSQL database, but I'm mentioning that because Kubernetes, for its inner workings, is going to use this particular technology for storing data. Okay. Another important thing is that the only the API server is able to communicate with it. So it's not that you want to query the database. It's not that you're gonna create these queries for, retrieving the key value items. You don't do that. Actually, the API server is the one that is gonna communicate to etcd, and that's it's abstracted away from you. Of course, etcd is one of the components in the control plane. It's quite important, and you should back up the data. It's not that Kubernetes has that functionality. It's not going to do that for you. So in a production environment, if you deploy Kubernetes on an on-premises environment, then you're responsible for backing up that data, the data that is inside etcd. Okay. On the other hand, of course, if you're using a cloud-based Kubernetes option such as Azure Kubernetes Service or Google Cloud, what's the name of Google Kubernetes option? Google Kubernetes Engine and AWS Elastic Kubernetes Service and those kind of offerings, then that backup functionality and responsibility is abstracted away from you as well. Okay. So the next component is the scheduler. For me, this is the most crucial one because this component is responsible for assigning work across all the nodes in the cluster. Its technical name is Kube Scheduler. Okay, this is the name of the service. If you execute, say, kubectl get services, and you inspect the namespace where these services are running, then you can see the Kube Scheduler service. That's the technical name. Okay. So this scheduler, as I mentioned before, it assigns work across all nodes. This is the responsible for analyzing your application and then deploying the application, or assigning the work to the nodes in the cluster. Okay, that's the responsibility of this component. And another thing about the scheduler is that it watches for newly created resources that have no assigned node, and it's going to assign a node for that particular pod. Of course, I haven't mentioned pods in this series yet. Just bear with me, okay, friends? This is the component that is going to assign that work for you, okay? And this is quite fascinating because it's going to analyze the current workloads that are running in your cluster, and it's going to analyze the free resources that your nodes have in that particular moment. I mean, memory or CPU or something. And it's going to decide, okay, this particular application, I'm going to deploy it to this node and this other node as well. Okay, this is a decision that the scheduler performs for you. So if we go back to the diagram, let me go back here. So the first, let me open up the EpiPen application. Okay, let me run this. Where is it? Okay, I have it right here in this other monitor. Cool. So let's say that you have your computer, right? Let's say that you execute this kubectl deploy thing, right? You want to deploy an application by using kubectl. So you execute kubectl locally, and this is gonna communicate to the API component. This is the first component that I mentioned. Then that is gonna be stored in etcd. I mean, the configuration, the thing that you want to perform is gonna be stored in etcd. And then it's gonna execute or ask the scheduler to deploy your application. Okay, this is how things are working right now with the components that I'm describing in this moment. Okay, so let me go back here and let's describe the next one, which is the controller manager. The controller manager, it actually is running all the time like a daemon or something. It's running controller processes that are watching if the desired state of things are the same as the current state. Let me describe that, okay? What you do in Kubernetes is to describe things. In other words, maybe with a YAML file, let's go here and let's create session 2. Okay. Let me open up Visual Studio Code because I just want to show you an example of a YAML file. Say, I don't know, example.yaml, and I want to use this snippet, okay? And I'm not going to deploy this. I just want to show you what's going on here, okay? So YAML files in Kubernetes describe things. They describe the desired state that you want for a particular object in your cluster. Say a deployment, which is, in this case, it could be your application, okay? So with this desired state, the controller, in other words, the controller manager is running all the different controllers in the cluster, and it's gonna detect if the desired state of things is the same as the current state. Because maybe if in your application you're saying, okay, you know what, I want, I don't know, maybe I want 10 replicas of this particular application, okay? I want this particular container to be running. I want these labels. I want these container ports to be open. All of that describe the desired state of things. And of course, I'm going to use that in the following sessions. Don't worry about that, okay? The most important thing about the controller manager then is that it's going to analyze what's going on with the cluster in that particular moment, and it's going to compare that with the desired state of things that you said before with your YAML files. And if there's something missing, or if there's a mismatch, then it's going to fix that for you, okay? This is the magic of Kubernetes, friends, because you just describe the desired state of things, and the controller manager, and of course the other components as well, are going to be sure that your desired state is fulfilled. That's magic, okay? And if something happens, if something is wrong, if there's a mismatch, then the controller manager is going to respond somehow. And it's going to ask the scheduler perhaps to deploy another application or another pod to this other node. And of course, we're going to see that in following sessions, okay? So a controller, what in the world is that? A controller tracks at least one Kubernetes resource type. So there's a node controller, there's a job controller, there's an endpoint controller, there's a deployment controller, and those different objects that we can deploy and we can use in Kubernetes, okay? So it's a watch loop, a controller, as I mentioned before. It's like a daemon that is running all the time. It's a watch loop that is continuously running and is watching if everything is okay. As I mentioned before, it's gonna compare the desired state with the current state. Okay, and finally, the Cloud Controller Manager. The Cloud Controller Manager actually is used only for cloud-based Kubernetes options, such as Azure Kubernetes Service or Elastic Kubernetes Service and those cloud-based offerings, okay? And this is because with this Cloud Controller Manager, the cloud platform can deploy different things, different services. For example, a load balancer. Say that you want to deploy this application and then you need to expose that application to the world, then you need a load balancer. And of course, it's not that you're gonna deploy your own load balancer, but you're gonna deploy the load balancer that is related to that cloud offering, right? And of course, there are many load balancing options that the cloud has. So this Cloud Controller Manager exposes the functionality so cloud platforms can communicate to the cluster and configure the cluster in order to know that this particular new service or component was deployed and you want to use, say, this load balancer with the cluster. So again, this is just for cloud offerings. For instance, I'm not going to use most of the time the Cloud Controller Manager in this series because I'll use MiniCube. That's why. But of course, if I deployed this, I don't know, a cluster in Azure or Amazon Web Services, of course, the Cloud Controller Manager will be a important and crucial component in that particular cluster. Okay. So I mentioned before there are two types of nodes, two roles in the Kubernetes world. And the first one was the control plane node. Let me go back here to the terminal because I want to show you, say, kubectl get nodes. As I mentioned before, I deployed this cluster beforehand to expedite this process. So I created 3 nodes for this cluster. And as you can see, the first one is a control plane. That's where all the components that I described are running in this moment, right? And the other 2 are the worker nodes. Those are the places where I can deploy an application. So for instance, Kubernetes, in this scenario, it only has 2 nodes, okay? It's not going to deploy my applications to the first one. It's not gonna deploy my applications to the MiniCube virtual machine. It only has M02 and M03 as available nodes, okay? So those are the places where the actual compute workloads can run, okay? And remember, worker nodes communicate to the control plane through the API server, okay? So I mentioned before the control plane components. Remember etcd as the key value store, the scheduler, the API server, the controller managers, and the cloud controller manager as well. And what happens with the worker nodes? Well, actually, they have their own components as well. When you deploy Kubernetes in a cluster, of course, you have a control plane, and the worker nodes, they also have components running on those computers or machines, okay? So let's describe the first one, which is the node agent. The node agent, its technical name is Kubernetes. The kubelet is an agent that is running all the time on each of those worker nodes. The node agent is particularly interesting and important because it registers the machine as a node in the cluster, right? So, of course, the agent has to be running all the time in order to be considered as part of the cluster, okay? So it also makes sure that containers are running in a pod. Of course, as I mentioned before, I haven't talked about pods, but don't worry, we're gonna talk about that in the following sessions. And it communicates to the container runtime through the container runtime interface, which is interesting. Remember that Kubernetes, it doesn't know anything about containers. I mentioned that the other day. Kubernetes, it doesn't know anything particular about containers, okay? What's going on here is that Kubernetes uses this container runtime interface, which is an interface, a public interface that container runtimes have to implement in order to Kubernetes to communicate to the container runtime. Just imagine it's like an interface, an abstract class or something, and Kubernetes is using that abstract interface instead of the concrete implementation of the runtime. Okay, so if you think about it, it's interesting because you can use different container runtimes in a Kubernetes cluster. For instance, I know that MiniCube is using Docker. I know that because the other day I showed you that. Let's remotely connect to this virtual machine. Let's do this. I'm here in this virtual machine, and I know that this is running Docker. As you can see here, it's running Docker 20.10.20, okay? And what happens with other Kubernetes clusters? Well, it depends on the deployment. You could be using Docker, and sometimes you could be using Containerd or Mirantis or some other container runtimes. Actually, for example, Azure Kubernetes Service uses Containerd by default instead of Docker as its container runtime. Okay. So let's go back to the node agent. That's why this is crucial. This is crucial for those worker nodes. It has to be running all the time. The next one is the proxy. The technical name is Kube Proxy. And this is a network agent that it's running on each node as well. And it's responsible for assigning a unique IP address to each pod. Okay, so if you deploy this, say this, I don't know, application that has 10 replicas, say 10 pods, then each pod is gonna have a unique IP address. Okay, and the responsible for doing that is the Kube Proxy component. And some other networking related things that I'm gonna talk about that in the following sessions. Okay, just remember that the Kube Proxy is responsible for assigning unique IP addresses to the pods that are running inside the nodes in a cluster. And of course, the container runtime, the node has to have a container runtime running, this is actually the software. This is actually the platform responsible for running containers. Of course, Docker is usually the most popular one. However, as I mentioned before, you have Containerd or you have Kubernetes. You have other options for running containers in a Kubernetes cluster. Okay. It's interesting because it's pluggable, as I mentioned before, through the CRI, through that abstract interface. So Kubernetes is going to use the interface, and the container runtime implements that interface. So Kubernetes doesn't have to communicate to that particular and concrete implementation of the container runtime interface. Okay. So CRI-O, Containerd, the Docker engine, Kubernetes, those are examples of container runtimes that we could use with Kubernetes. Okay. So maybe you're asking yourself, why in the world I want to change the container runtime? Well, actually, it depends on your current skills and how the Kubernetes offering that you're using was configured. For instance, as I mentioned before, Azure is using Containerd as the default container runtime, while MiniCube is using the Docker engine, right? But actually, it's not that you're gonna mess with that. It's not gonna. You're not going to worry about that. Actually, that's part of what Kubernetes does for you. Okay. So let me go back to the terminal before I talk about those managed Kubernetes options. Let me go back here and let me execute this other command, which is get service. It could be get services as well. And let me inspect the, what's the name of the namespace where all the services are running. I can't remember the namespace. Anyways, I just wanted to show you the where all the control plane components are running. Anyways, I'm going to show you that in a little bit. Just remember that those components that I mentioned before are running in those nodes. And this is a service that I'm showing you right now is one of the services that by default is running when you deploy a Kubernetes cluster. Anyways, before I showed you the managed Kubernetes options, because actually this is related with Azure. This is because the material and the training contents that I created were created for Azure. However, just take into account that this same applies to Amazon Web Services or Google Cloud Engine and so on. Okay. So let's talk about those managed Kubernetes options. So the thing about Kubernetes is that it's not super easy to manage that control plane node and those different components that are running all the time. Okay. So another thing is that you're responsible for maintaining your Kubernetes cluster in terms of course, you have to patch your operating systems. You have to upgrade your operating systems. You have to do, I don't know, maybe if, maybe if hard disk was damaged somehow, you have to replace that hard disk. So you're responsible for everything. You're responsible for every single thing that happens in that cluster, right? So that's why we have some cloud offerings such as Azure Kubernetes Service. In this case, I'm going to talk about Azure Kubernetes Service because the training contents were created for Azure. However, this is not Azure specific. Remember that I want to describe and explain things related with Kubernetes only, right? Vanilla Kubernetes. So those cloud offerings, they have the control plane deployed for you and managed for you. Remember that I'm talking about this, the control plane. Remember the API server, etcd, key value store, the controller managers, the scheduler, those kind of things. So if you happen to use those cloud offerings, then this control plane is going to be deployed for you and managed for you. Actually, this is a free, you don't have to pay for that. This is a free node that you'll have when you deploy a Kubernetes cluster in the cloud. You only have to pay for those worker nodes that you're using. Okay, only this nodes. So let me go back here. Where was I? Yes, here. So the control plane is going to be managed by Azure, AWS, Google Cloud Engine, and so on. Okay, you only manage and maintain the worker nodes. You only pay for that, and of course, the cloud Kubernetes that you're using, it can be integrated with Azure, with other cloud services. For instance, if you deploy a load balancer, then you can integrate that load balancer with the Kubernetes cluster that you deployed. In particular, with Azure, Containerd, as I mentioned before, is the default container runtime. Okay. And this is specific for Azure. There are many ways to create an Azure Kubernetes cluster. You can use the Azure portal. You can use the Azure command line interface. You can use PowerShell. You can deploy your cluster by using an ARM template, a Bicep application, Terraform, Pulumi, or whatnot. Okay, there are many ways to do this. Actually, in this code that I'm showing you right now, this is the Azure command line interface command that you can use for deploying an Azure Kubernetes cluster. And you know what? I executed that beforehand in order to expedite this process. So I executed this AZ, which is the Azure command line interface command, AKS, which is the subcommand, and then create. I used this resource group, which is Kubernetes Fundamentals, and the name of the cluster is AKS cluster and some other things. And I deployed that to my Azure account. Actually, I can execute this Azure AKS list with output as a table. And as you can see, I have to zoom out a little bit. So I have this AKS cluster that is running on South Central US. Why is that important? This is because I wanted to show you some other commands related to kubectl. Because yes, of course, I'm executing get nodes and I'm executing get services. And then I'm talking about namespaces. But you know what? I decided to wait a little bit because I need to explain some other things related to kubectl and how nodes work and how applications and paths and those primitive objects work. That's why I'm not explaining a lot of things with kubectl. Okay, I just want to go little by little here. Okay, just bear with me, friends. Okay, cool. So, right, I know that kubectl is this command line interface tool that I can use for configuring applications and inspecting the cluster and some other things. Okay. But actually, kubectl is quite versatile because it allows me to connect to many different clusters. In other words, I can switch from context to context, okay? So let me show you a couple of commands in this session. The first command is kubectl config get contexts. let's execute that. Get contexts. Okay, let me clear the screen and execute this again so you can read it better. So as you can see, in this kubectl installation that I have here on my machine, I have 3, 4, 5, 6, 7, 8 different contexts configured. Okay. Why is that important? Well, the thing is that, as you can see in this column, I have the star. That means that MiniCube is the default context that I'm using. This is the current context that I'm using. In other words, if you execute any command, such as get nodes, this execution is in the context of MiniCube and only in that particular context. Make sense? So I already deployed an Azure Kubernetes cluster in the cloud for this session. And as you can see here is the first one in the list. This is the name, AKS cluster. Okay. I already merged the credentials required for me to connect to the cluster. Actually, that's another command that I want to show you. I already done that, and I executed this other command as well. This other command, again, this is only for Azure. It's going to retrieve those credentials, and it's going to merge that credentials to my local kubectl configuration. Again, I've already done that in order to expedite this process, okay? That's why I have this item here in this list. Another command that I want to describe in this session is use context, okay? Kubectl config use context, and then you pass the name of the context that you want to use. In this case, AKS cluster. So as you can see, I switched to the AKS cluster context. Let's execute again, config get contexts. And this is my current context. So if I execute get nodes again, as you can see, I have different output because of the fact that get nodes is running and it's executing on the context of the AKS cluster that I deployed beforehand. Make sense? So that other cluster that I deployed before we started today, this session, I decided to have 3 nodes as well. But this is just a coincidence, okay? I could have deployed, I don't know, maybe 10 nodes or something. I executed the following command. AKS create, I passed the resource group, the name of the cluster, the node count. As you can see, I'm using 3. Of course, you can change this to any value that you want. And I used other flags for adding some other things that I'm going to explain in other session. The most important ones are those 3, okay? So I deployed that cluster in my Azure account, and that's why I have those nodes. I don't have any application yet, okay? I just want to show you what's going on with this context switching with kubectl. And actually, I think this is a question in the certification exam. That's why it's important. Even if you're not pursuing the certification, this is what you do when you're managing different clusters with your kubectl tool, okay? So let me go back and use config use context. Let's execute this, and then MiniCube, and we're back to the MiniCube context. And then if I execute get nodes again, I'm retrieving the information about those nodes that are deployed in MiniCube. Awesome. There are many different commands that we're going to use in this series, such as get nodes, of course. That's the first one that I'm using since the previous session as well. However, we're gonna use get services and get pods and some other things, and I'm going to explain namespaces, and I'm going to explain some other things in the following sessions. So bear with me. Okay, so this is node pools. This is an AKS topic that I don't want to explain right now. Again, because I want to explain vanilla Kubernetes in this series. Cool. So before we end this session, let me delete my MiniCube cluster. This is another command that I showed you the last session. With this command, you're going to delete all the different virtual machines that were deployed by using MiniCube. As you can see, those virtual machines are being stopped and deleted as well. So maybe you want to do that in your own machine, so you don't have those those nodes running all the time. I think this is a great option and idea, so you don't have those things running all the time. Cool. So in the next session, we're going to talk about Kubernetes fundamental resources, mainly pods, and I'm going to talk about deployments and services and some other things. So there are many things that I want to explain and I want to describe. Of course, we have to go little by little, okay? Step by step. Awesome. So yeah, with this, let's wrap up. Thank you very much for your time, friends. In the following session, we're going to talk about Kubernetes fundamental resources, and Happy New Year, and see you next year. Actually, see you next year, and in session number 3. Thank you very much for your time, and take care.